how does my body ensure that neither of these happen? I'm going to ask you to the first time you call the phone. Okay. Now, why would that be important to us as organisms? How does my body maintain that it doesn't do either of those? Homeostasis. Because at homeostasis, what temperature, hopefully, is my body going to be? 98.6. And the hope is that that's going to occur. Now, water, the other properties that are going to happen, the other properties are going to be that water can be cohesive and adhesive. Now, the importance of that we're going to find is for movement of materials through my body. All right? We're going to see that become very important. So in the bonds that are going to form when we put elements together, we're going to have ionic bonds, covalent bonds, and hydrogen bonds. Ionic bonds are very strong. Covalent bonds are going to begin, they're going to be strong, but they're going to begin to not have the strength that ionic bonds do. Hydrogen bonds are going to be probably, of all of them, what they consider the least strong. However, you get two or more hydrogen bonds together, and they are very strong. Hydrogen bonds are so strong when you get two or more of them together. It is the bond that exists in our DNA, where you're going to have A to T, G to C, okay? Hydrogen bonds are holding it together. And that is an extremely strong molecule. Now, there's going to be another bond that we're going to find exists, and that's going to be a peptide bond. This is going to be the bond between amino acids. What do amino acids, when they're bound together, form? Proteins. What is the only thing the cell can produce? Proteins. If we begin to think about the importance of the bonds, we have to remember the only way that we get materials, for the most part, the way that we get our materials, we consume them. All right? How many of you have had breakfast and lunch today? Both or just one? Breakfast is the most important meal of the day. Okay, now, we have to give these materials their ability to be soluble becomes important. The body is going to use materials. The body can break stuff down. The body can build stuff up. Now, when we have materials, their ability to dissolve is different. Not every material will dissolve the same. When we talk about how soluble, the solubility, the ability of one substance to dissolve in another. For example, sugar or salt in water. If I were to take this water bottle right here, pour a little bit of salt in there. All right, let's say I just fill up the little cup in my hand. All right, put this in here. Wait a couple of seconds. Swirl. What will it do?
Dissolve.
It'll dissolve. But let's say that I take and fill my hand up and put it in that bottle. What's going to happen?
It's gonna saturate it.
I'm going to saturate it, and some of it's going to settle. Okay? Now, there's a reason for that. Once again, let's think back to the water in our body. Okay? When I take something such as sugar or salt, other materials too, I mean, fats, proteins, okay? I take them and I eat them, okay? And they're going to go into my stomach for digestion. The entire time, from the minute I begin to take in that substance, from the time the body breaks it down, utilizes it, it's in contact with water. Sugars, salts, proteins, fats, okay? Especially our salts. Because the salts give us the ions. When you take in salt, all right? Now, when I was growing up, the salt we had, okay, the only one we ever had growing up was the good old Morton, you know, the little container of Morton salt with the little girl, you know, with the umbrella, all right? You had the little flip thing where you flipped it up, and then you had the Tupperware, y'all probably don't know what Tupperware is, the Tupperware salt and pepper shakers, okay? You love to fill that up, all right? That was true salt. It probably contained everything I needed. Probably contained the sodiums, the potassiums, the magnesiums, the zincs, iodine. Because you would see on the label, iodized. When you go to the store now, what do you see for salt?
They say you get enough from what you're, like today, you get enough from what you're eating.
I tend to beg to differ.
They said, like, what I read was like, a long time ago, they didn't have enough iodine in the food they were eating, so they put iodine in salt. Now they can take it out because they get enough in the food they're eating today.
Yes and no. But that's like a whole nother topic. The reason that they say we get enough salt from our diet is because we're eating so many packaged, processed foods. All right? Eating healthy costs a lot of money. Most people cannot afford it. Okay? It's easier to buy something frozen, all right, or go through a drive-thru and get the dollar special. All right? Let's face it. That is not good food. All right? Now, not a good source of iodine is what you see on a whole lot of the salts now. They will still have sodiums, magnesiums, zincs, potassiums. The job, you know how when you look at salt, salt looks like it's a little cube? Okay? Because that's the form that it usually takes when it precipitates out. And you'll have this cube be the bonds that have formed between those elements. Now here's what happens. We take them into our body. In our body, we have a lot of water, okay? Look what the water does. Because water has a little bit of the negative and positive charge. When this cube enters, do you guys remember how one element has given up an electron, one has gained, and therefore they are now charged? One of them is positive, one of them is negative. Well, once again, if my water has negative and positive, and these are negative and positive, what do opposites do? Opposites attract. Water is able to take the materials and break them apart. So the negative element will get surrounded by the positive side of water. The positive element gets surrounded by the negative, creates a sphere, all right? And now I'm able to have in my body pluses and minuses. Now the chlorine portion, that's going to be negative. However, we still use chlorine in the body. But sodium would be positive, magnesium would be positive, sodium, magnesium, potassium, okay? All of these would have a positive charge. They're now available in my body. That means they can go and play a part in these reactions that have to occur. For example, with nerve cells, I would be able to conduct a nerve impulse. For a muscle cell, I'm able to make it contract. Does that make sense? Because I have now given my body the electricity. Think about electricity in a wall, okay? How does it function in that electrical line? We have alternating and we have direct.
Basically, the electricity is at the outlet until you plug something in and use it.
It works off of negatives and positives, okay? And same thing is happening in our body. Now, that's pretty cool, all right? It's the reason that if somebody's, I don't know, say their potassium, for example, is too high. If their potassium is too high in their body, their muscles and their nerves, for example, are lethargic. Nerve impulses don't go very quickly. Muscle contraction doesn't go too quickly. Now, when I said nerve and muscle, what parts of the body did you think about?
Nerves and muscles. I think about the heart.
Most people wouldn't, but you're with EMS,
Right.
so you do. Most people would think arms and legs. But remember, we're going to learn 3 types of muscle. We've got our skeletal muscle, which we see as the arms and the legs. Cardiac muscle, which we see as the heart. Smooth muscle, which are our organs. Now go back to what I just said. Potassium level is too high. It is going to make nerve cells, muscle cells, lethargic. I don't just mean skeletal muscle. People can go into cardiac arrest, and it will kill them. So are you kind of following me on the importance of these electrolytes for electricity of the cells? Stop me now. if you have questions. Okay, so when we take the chemicals